All right. Lastest but not leastest by any means. Thanks everybody that hung around here in person at the Acquisition Research Symposium, and also for all of those that are online. I am Randy Pugh. I am the director of the Naval Warfare Studies Institute at the Naval Postgraduate School, and it is my tremendous privilege today to moderate this panel, which is really a continuation of the previous panel on artificial intelligence and acquisition. And then also, I think it's going to complement the comments that you heard from the last panel with the papers that will be presented by the three panelists. So one of the great privileges of being at the Naval Postgraduate School and being on this stage and being here with this audience is that it's filled with smart people who are incredibly insightful. The downside is that everyone took all of my points earlier, either in Admiral Rottenhouse's opening comments or the questions that came up. But I would like to just take a few minutes to set the context before the panelists are introduced and talk about their research. And one of the comments that came up last panel is that AI is not new. So the term was coined, I think, in 1956. In 1952, somebody wrote a computer program that learned how to play checkers. And then AI has been, has been steadily increasing in sophistication and utility since that time and even before. But what I think a lot of people are not aware of is that it's not a steady state development of AI or AI-related capabilities. And there were two super bloom periods, I call them, for artificial intelligence. And one was at the end of the 60s and the beginning of the 70s. And that was looking at speech understanding and machine translation. And everyone got super excited about it. There were tons of dollars that were provided to researchers and all kinds of activity and excitement around artificial intelligence. There was another super bloom period that took place, a spike that took place in the 1990s, and that was related to expert systems. So having the computer be your your workmate and being able to have near real-time answers to really complex questions. What happened at the end of each one of those super bloom periods are what are called the AI winters. And so everyone was completely liquored up at the beginning. All these research dollars went into AI-related research in private industry, in the Department of Defense, in international research and development efforts. That was then followed by disappointment in the results. Expectations were not managed. That was then followed by a precipitous drop-off in research funding, the ending of those research programs, and then this kind of period of desolation following the AI winter. And so now we're in the third period of excitement and hype and everything else about AI. And really, I mark it with the start of it with the release of ChatGPT from OpenAI. There's many other tools that were mentioned previously by Ryan on his panel. But really, OpenAI and ChatGPT being a capability, but then also made generally available to anyone that had an internet connection. And so you had, I don't know, 2.5 billion users that could jump on and play with it, learn to do prompt engineering, ask it interesting questions, and meanwhile the system is learning from all of that. So this, at least to me, and I've been looking at this at least for the last 25 years. I wrote my thesis at NPS on AI, and this one feels a lot different for many reasons. We talked about the computing capacity, and we talked about the availability of data. We talked about the kind of the readiness of data to train models, those kinds of things. And so, whether or not we're going to have a third AI winter, I guess is debatable. You never expect that you're going to fail, maybe. And I think for this audience, when we talk about the Acquisition Research Symposium, or we talk about the acquisition profession, a lot of that is going to be about cost, schedule, and performance. And most of all, transitioning R&D or neat, creative, clever technologies into capabilities and crossing that valley of death, and to do it for artificial intelligence. And so somebody on a panel yesterday I was sitting on said, they got a hold of ChatGPT. Everyone's kind of a novice, but they're intrigued. So jumped on ChatGPT, and he said that it went from, hey, that's neat, to like, wow, that's really useful, to using it as a day-to-day tool in a period of like a week or something like that, because it's so easy to use and it's so useful. So I am proud to say that the prompt that I gave ChatGPT that said, create me opening remarks for a panel related to artificial intelligence and how it applies to defense acquisition, it did a pretty good job, but I chose not to use it. But what I would like to, just to keep the mood light and maybe highlight how this may be different than previous AI periods of excitement. There's an application called ChatPDF. Anybody use ChatPDF before? Okay, write it down. It's the coolest thing ever. You drop a PDF into the app, and then you can ask the document questions. And so I dropped the National Defense Science and Technology Strategy into ChatPDF, and then you can ask it questions. So I said, what role did the private sector and academic enterprises play in supporting the systems on which the joint force will depend? What are the most important emerging technologies? Summarize the document, please. And I like that I say please to the robot. What are the keywords that define this document? And then, you start to get kind of wilder and wilder as you go along. Like, I wonder how far we can stretch this. So the next one was summarize this document in a haiku. And ChatPDF in 1 second came back with modernize defense tech, invest in emerging fields, stay ahead of threats. So then I asked it, summarize this document like Dr. Seuss. And I got, in the land of defense where threats do abound, the DoD has a plan to keep us safe and sound. They'll invest in new tech and protect it with care, engage with the private sector, and stay ahead of the snare. Emerging fields are key. Get more laughs than me, ChatGPT. Emerging fields are key to staying on top, and with China as a rival, we can't afford to stop. So let's sharpen our edge and be proactive too, for the future of defense depends on what we do. So like that coming back when I'm like, oh, the robots are going to enslave us like fairly soon, because that is incredible. So this topic, as I mentioned, is about the Venn diagram overlap between artificial intelligence and acquisition. I think it's an especially rich topic, and some of this came up in the last panel discussion, which is certainly we're going to have AI in all of the systems that we want to acquire. And so there's all of the the complexity and interdependence of trying to understand, how do I write a requirement for that? How do I cost that? How do I manage risk for that? How do I test that? All of those kinds of things. There's also, and you'll hear that from this panel, AI to support the acquisition pipeline or the acquisition process. So can I use, and it's on the last panel too, can I use ChatPDF, to mine an RFP and pull out the most important aspects that need to be addressed? And then there's acquiring and maintaining AI tools for all of these things. So these are, the maintenance tools for the physical systems of previous generations. What does that look like for AI? And then mostly, and most importantly, is acquiring, sustaining, and enhancing AI talent. And so, the generation, my kids' generation, are certainly going to need new knowledge and skills and the ability to use different kinds of tools in new ways that are, in my opinion, more revolutionary than they are evolutionary from the industrial age. And so for anybody, my utilization tour when I graduated from NPS, I went to Marine Corps Systems Command. I was a project officer acquiring software intensive systems for program manager for intelligence systems. And so I think at the time, like, there's nothing more risky or more complex than acquiring, a software application. It's just filled with ambiguity and cost and risk. I think acquiring AI tools or doing AI for the acquisition community is going to be like acquiring software, only exponentially more complex and exponentially more risky. So before we begin, quick rules of engagement. What I would do, I'm going to introduce each one of the panelists. Each one of the panelists in turn is going to present their papers for about 10 to 15 minutes. I would ask while they're presenting their papers if you could write down your questions or put them in your head. Ask ChatGPT what you should be asking about the topic. And then as soon as we have the last panelist finish, we'll have time for questions and answers, and we'll just we'll go until we run out of time. So with that, if there's no questions or contentions of my rules of engagement, I'd like to introduce our panelists. So first on my immediate left is Dr. Jose Ramirez-Marquez. He is an associate professor and division director at the School of Systems and Enterprises at Stevens Institute of Technology. He earned his Master's of Science and PhD from Rutgers in Industrial Engineering and a Master's in Science of Applied Math from the National Autonomous University of Mexico. To his left is Major Iain Cruickshank. Major Cruickshank is a functional area 49 or an operations research systems analyst, good, Marine guy, in the US Army. And he is currently a senior research scientist at the Army Cyber Institute at West Point. He holds a PhD in societal computing from Carnegie Mellon University and earned his Master's of Science in Ops Research from the University of Edinburgh. And then on the far left is Ryan Longshore. He is an electrical engineer at the Naval Information Warfare Center Atlantic. And he earned his Master's of Science in Systems Engineering from Southern Methodist University. And he is currently a distance learning PhD student at the Naval Postgraduate School. So if you could please, a round of applause in advance for our three panelists. And without further ado, Jose, I will turn it over to you, sir.
Thank you so much. Thank you. Let me apologize first because I'm not an acquisition person. But I keep coming here, you know, and so so I guess that's something. So this is my third time here. I've been visiting since 20 years ago. First as a panelist on system readiness level, which created a lot of controversy. Then on resilience for the acquisition system. And now I ended up on this area of using AI for natural language processing. And so I'm very happy. I guess I'm more than a guest now. And so what I'm going to talk about today is it's a project that I started a year ago, and my co-authors are here, and not only co-authors, but advisors, and they helped me frame this work. And so this was really a project that was a 2-month project, and usually what we faculty do is find a student and get the student to work our ideas, and then we actually write the paper, right? Well, it turns out that since this project was so close, I did it so short, I didn't have a student. And so I'm the student and I'm the professor, right? And so what's this about? This is really about finding and you saw in my title, it says semi-automated. Well, we want to get rid of the semi-automated and make it an automated process that we can kind of push a button and say, hey, here are some skills that are representative of what the general workforce needs. And when I say general workforce, I mean, it would be good if we could start slicing that up into different areas. And this one is for specific, the acquisition workforce, because we want to know what are the skills that are necessary right now. And so, as you can see, the objective is we want to identify areas of expertise and allocate resources accordingly. I think that there's going to be a lot that we can do afterwards, not only identifying skills, but mapping skills. This, I would believe, would be a better version of what we really want. And so this has two phases. The first phase is the actual data extraction, cleaning, and developing for it to become kind of a database that we can put in and create the analytics. And so what you're going to see is basically the approach that we took to identify this. And so first part, data collection. We'll get that data. By the way, this has to do a lot with the previous panel. And so the first talk that you heard about, or the ones that presented, talked about, well, what type of application? So this is one application of AI specific to the acquisition. And I think it was Ryan who's doing the verification. So there's a lot of work that needs to be done to verify what AI can do. And so, and I'll get a question from him, but I'll try to preempt it in what I think are the areas of validation that are important. By the way, we could do this with what you talk, chat PDF, right? And so we could just input whatever report into chat PDF and ask chat GPT PDF. I don't know. I don't use please. So there's two camps. I just say, do this, and it actually does it. And so one could be create the framework, right? Or create the skills from all these reports or PDFs. This was a little bit more organized. And so here's one of the first experiments, right? Is there a difference between these two approaches? And so one approach is just fill it, do it with the chat PDF. This one has to do a little bit more on skill identification. And so we actually create a code that extracts from all these different documents the context of the word skill, because that's what I'm interested. I'm interested in identifying skills, but I don't need a keyword. I need the context of the keyword. And so that's where you see the keyword extraction information. And so information, why? Because from that extraction that we get, we create a summary. You would get a summary of skills. So I'm missing. And so here's the example of the phase 1 implementation. Here's one report. This is the Defense Business Board. And it's got 95 structured pages. You would have to read this and extract whatever keyword that you want to do, and then create a summary. And so what the code is doing is just extracting skills, the whole context of the skill, and then it's summarizing it. And so what you would get is a summary that looks like this, right? And describes what are the skills. Here's another example. This is for Deloitte, and it's 28 structured pages talking about skills or talent management. And so again, we extract keyword context, and it's summarized in this way. Why do I want the summaries? Because the summaries then are going to be used in phase 2, which is actually the skill identification and the text analytics that we want to create. And so think about that. We want to create these maps of skills and what type of different skills are being shown. These reports were provided by my co-authors, thinking that these are the relevant reports that should be looked at. But this is an ongoing research, and what we're doing right now is creating a database of all these different documents that talk about a skill identification, or about talent management, or about future skills. All right. And so the first thing that we do is, this is our verification approach. We want to see that the summaries are actually related, right? And so we need to find that there's some similarity. If they were not related, then everything would look quite yellow, and we would say, oh, well, these documents have no relationship among them, right? So this is kind of a verification approach to see that what we're extracting makes sense. Not only that, you can see here different areas that are colored, and these are the documents that relate most to each other. And so another categorization could be is what are the skills related to these different heat maps, that different values that you see in the heat map. Once this done, there's two ways of going through this. We went through the diagram and clustering approach. And so what we created was code that extracts the diagrams out of those summaries all together, and then provide clustering of that. And so what you get is something similar to this. So this is cluster 9. You can see all the diagrams related, and it's related to just one document. And so here's another example. This is cluster 9, and it tells you which one is actually coming from. And so where does AI come in, and where does ChatGPT come in? Well, so since we want some contextualization of these diagrams and clusters, that's where AI came in. So the question was, can you provide structure to these diagrams? And that's the structure that was generated. And so from here, two things come out. So, this is the summary, or an executive summary of the type of skill that you could get. And the second one is the networks analytics, and trying to create a semantic network based on semantic clusters. And so we used a Louvain community detection approach. And what we really want to create is this type of network, or what I call a skill map. And so the several clusters would define what type of skills are necessary by these different clusters, and where are the relationships that are being generated, right? And so again, ChatGPT is just being used here to define the title for the clusters. And so this is where we stand. That's what the semantic area. There's some problems. I don't want to talk about the problems, given that I've already taken some of the time. But so moving forward, what is the perspective? So we want then to map skill sets, right, or requisition of a skill set into these different clusters to understand better the skills that we're getting. And so that's my part.
Very good. Thank you. If everyone can just hold their questions until we get through all three briefs, please. Major Cruickshank, you're up. There we go.
Well, good afternoon, everyone. I'm Major Iain Cruickshank, and I'm joined by my colleague, Major Shane Kohtz, seated right over there. And we're going to be talking about our research on planning for AI sustainment. And so to kind of kick this off, I want to begin with, much like Professor Ramirez-Marquez, I am not an acquisitions professional. I'm a data scientist and a machine learning professional. But as we've heard from a lot of the talks and some of the themes of this conference, a lot of the rapid innovation or innovation at scale comes when we're able to get experts together to look at some of these problems. And so Shane and I have really been trying to do that over the last couple of years, and started this is our second year coming to the event, this sort of path of research on this, where we take our two different expertise and we try to look at what are the barriers to being able to get good AI-enabled technology for the force based on our kind of different positions. So as I go through these slides, I'll also kind of point out where I see things from my foxhole as a practicing machine learning engineer and data scientist that I wish we would acquire or do better with when we acquire things that have AI-enabled models in there. So I'll try to point those out. There'll be two of them in here. So this year, our research question is a fairly simple one. What we wanted to do is we wanted to say, look at it, is there a methodology where we can estimate how much does it cost to maintain an AI model? So if I have some kind of AI-enabled system how much will it cost to maintain the AI portion of that system over the lifespan of it? So to begin with, and to give a little bit of background on where does this come from, the first thing, and this is one of the big points I want to hit at here, is machine learning models that power artificial intelligence require maintenance, all of them. That's important because oftentimes I have seen, Shane and I both, programs that don't consider that. They think once you buy the model, it's done. They have to be continually maintained, just like every other piece of technology. So in last year's work, we really dug into that and we said, well, what does that maintenance mean? What tasks become that maintenance? What do you have to do to maintain them? And within the figure you see there, that's where we sketched out what are these kind of maintenance tasks that would be needed for an AI-enabled system. As part of that work, what we proposed was a hybrid approach to maintaining machine learning models, in that there are some tasks, due to the complexity of the task itself or the high level of skill required to execute it, it's best left to contractors to do. You can think of this as almost depot level maintenance that you might have to do on a physical thing. But then there are some that's actually better for services to do. So this could be something that there's a service member who's trained that actually executes those parts of the maintenance task. And so we had proposed this idea, and this is good, but what it left was, they didn't really have much meat behind the idea. And so this past year we said, well, let's see if we can actually put some numbers behind this and really see if there's a way we can estimate that and show whether a hybrid approach is better than just simply contracting out all of the maintenance considerations, which is usually the default that we often opt to for a lot of these AI-enabled systems. So with that idea in mind, the first thing we did was we thought about, well, how could we measure kind of the cost of doing this maintenance? And so this function you see at the top is just a very simple function of how we went to estimate it. There's sort of three big axes when it comes to doing maintenance on machine learning models. So the first one is the tasks that you have to do. Like this could be data and model monitoring. This could be model fine tuning. This could be actually implementing the model in the first place. This could be model certification around things like robustness and fairness. The second part of that is, and closely related to it, is what kind of skill or expertise does it require to execute that task? So it requires much more skill to do something like certify a model as robust and resilient than it does to, say, monitor the model for performance. So there's two kind of related components to it. And then the third part is well, how often do you have to do that? How many times or how much time does it take for this person to use their skills to execute this task? And how often is that going to occur for this machine learning model? The last summand you see on kind of the outside part of this figure accounts for the fact that you can have AI-enabled systems with multiple models in it. In fact, if we think about the push towards AI agents coming into being now, that's likely going to be the future of things. In fact, I think some of the other panelists have hinted at this as well. You may have like a large language model that handles things like translation of instructions to code, but you may have another AI model that actually executes something like vision classification or some kind of planning piece of this with approximate dynamic programming or some other aspects of it. So with that function in mind, we then wanted to explore kind of a realistic use case that we could use to estimate this cost and look at it for some kind of a program. What one we picked here is one that's common to, I think, all of the services, and some of them have it implemented in various forms already, and this is automated threat recognition, or ATR. And so the idea here is it's a fairly simple system when you think about it. You have a sensor. This could be visual spectrum, EO, IR, something like that. And then you have a computer vision model that is typically doing the task of object detection. So it takes that images from the sensor and then it says these are the particular objects within it. And then you have the supporting hardware that runs all of these components. And that's kind of the system to think about in your mind here with this. And what we wanted to do is we used an example of basically a standard Army brigade. I think we opted towards an armor brigade. So you could imagine you have tanks and other armored personnel carriers mounted with this system that they would use as part of normal operation. So the next part is well, how often are they going to use this? So for this, we just looked at usual training calendar timelines. So you can imagine there'll be per year some kind of CTC rotation, or you consider a deployment. There's usually around 1 to 2 major brigade training exercises per year, and then various other ones that can be sprinkled about as well. For each of those events, we can then look at what kind of maintenance tasks would have to be performed for those events. So you can imagine if we're going to CTC, there's going to have to be a pretty major data collection and labeling event, followed by a pretty major model retraining event. With those, we then took basically median industry rates for things like a data scientist, for an E6 in the Army, for CW3 in the Army, and these types of skill premiums for these work roles, and we can use that function to now estimate what would the cost be if we change these around and change these parameters with this. And so down there in the sketch is kind of the rough idea of how this maintenance would work. You have these vehicles that are deployed with the AI-enabled system doing their function. There's going to be some maintenance that goes back to something like the talk where you have some kind of equivalent of the ML maintenance team that handles functions like model monitoring, model tuning, data cleaning and labeling. And then there's some kind of rear where you have that depot level maintenance where you're going to see those more higher expertise, higher complexity things like model certification and renewal, as well as maybe supplementary work like additional contract work for data labeling and collection. So having developed that, what we can then do is we can just simulate it, right? We can run this simulation over multiple times and we can spin it out over the life cycle of this particular AI-enabled system. And we can say, all right, if we go by contractor rates for everything, what is the cost estimate? If we take some tasks that are capable of being trained for service members and then we spin it out, what's the delta in that? And so this graph at the top shows you this sort of sensor payload with the ATR model in it for one brigade over a 20-year lifespan of a contractor only rate, which is basically we're going to pay contractors to do all of the maintenance. The only thing a service member does is just look at the screen, versus one where we're going to have some elements of the warfighter executing those maintenance tasks. And there's a large delta there. It's over $1 million over the course of that lifespan. That's just one brigade. As part of that, the two kind of, again, as I hit on this before, ML models do add maintenance and they're not a non-zero maintenance cost to a system. So if you have a system and you're like, well, let's sprinkle some AI on that, that's going to come with a maintenance cost, in addition to the upfront cost of possible model development in the first place. One of the big things we found in this, though, is the big drivers of this maintenance task are often these sort of low to mid-skilled tasks. These are things like model monitoring, data labeling, data collection, and model retraining. These happen with a high degree of frequency, but they're actually not that hard to execute. Given a proper, basically a technical manual or a field manual for the system, it's possible really for a trained service member to execute a lot of these. And that's why, again, we see, or we would propose there should really be a hybrid approach whereby we take these low and mid-skilled maintenance types of tasks. So again, this model and data monitoring, model retraining, and have those performed by the services in situ, and then these other more expensive things like model renewal and certification with this executed by the contractors. So again, this is now this graph here. So we mentioned, right, this kind of system with it. There is the machine learning models themselves, but you also got to remember this is additive to the hardware that is required, as well as the underlying software in order to run these models in the first place. And so in this graph, what we've done is we've taken now those costs based on a similar sensor payload program, added that into it, but then we looked across the 9 armored brigades that would exist with something like the Army and then spun that out over the course of a 20-year lifespan of a program. So once again, you can see there's, it's, potentially up to a third of total sustainment costs can come from adding in these machine learning models to a program. But a significant way to buy down that cost, and frankly, I would argue the risk as well of using these, is if we move some of those tasks, some of these like high frequency but low skill tasks to actually be executed by service members at the front, at the field with these. An important point we'll put in here as well is programs really should conduct some kind of a touch time analysis with this. A lot of the machine learning model maintenance is very context dependent. So some models, especially if they're trained for a very specific task, something like object detection from satellite imagery or something like that, are going to be very sensitive. And so they're going to require a lot more maintenance because every time you say, you look from the back 40 at Fort Liberty to CENTCOM AOR, it's going to have to be changed. You're going to have to collect data, you're going to have to label it, and you're going to have to retrain that model because it's sensitive to those approaches or sensitive to that background and that context. Other models, like large language models, are more context insensitive. But just as we saw this morning when the panel asked, right, like How many have used ChatGPT? Most people raise their hands. How many get perfect answers? Nobody raises their hands. They still have to be updated and maintained as well too. Like they still have to be adjusted to the domain in which you're going to operate. The other parts that kind of come with this, and I think this would be, so my first thing is, again, for all acquisitions professionals, understand that machine learning models require maintenance. Doesn't matter what they have to. The second thing with this is buy things that can be maintained by service members. Almost without fail, the things we buy you buy it, and then you might even have somebody like me that's capable of maintaining it. I can't do it because there isn't dual use rights over the data or model. And it's not, the only thing the service member ever sees is the dashboard. They don't have access to the data and they can't in any way change or alter the models within it. So it's important when you're adding these things in there, you make them maintainable by service members as well. But the other part to point out here too is also remember there is an important role played by the industrial base with this, right? Like building these things like a large language model base from scratch requires a significant amount of expertise and resources, and that's frankly best left to contractors rather than trying to build that within Uniform. But the maintenance of it, that might be something best to do with Uniform with that. And so I think those are really the big points with this, but this was our project this year was to put some meat behind this idea of we need hybrid sustainment of machine learning models and present a methodology for doing that. Thank you.
Great, thanks, Iain. Ryan?
Thanks. All right. Okay. So I'm not sure how to go back a slide, but that's all good. Okay. So I'm Ryan Longshore. I am not Dr. Madachy. He is much more dynamic speaker than I am, so I apologize in advance. But really to kind of frame where we're coming from on this problem. So back when I was an undergrad, I was mainly a C programmer. I was an electrical engineer. Of course, AI, that was after one of the AI renaissances that had failed back in those days. Coming through graduate school, the first time I got involved with Python, started using it pretty heavily, worked out pretty well. And then I met Dr. Madachy here at NPS. We started using Python in his modeling and sim class, and then used it again to do some machine learning and one of his system safety classes, trying to predict failure of machines using machine learning models, which really got me interested. And then we started our work together, doing some research, and Dr. Madachy has started building a library called SC Lib, which is a Python library for open source systems engineering. The really cool thing about that was we discovered really quick when we added ChatGPT into the mix, some of the solutions weren't elegant, but they at least got us going down the right path. And they drastically improved how fast we could add functions to the library when we had a good starting place. So I gave you the background. Would I trust ChatGPT with C programming? Probably not. That's just me. However, it has come a long way, and it's really a force multiplier. So I want to preface the conversation or my brief with, we're not necessarily trying to replace programmers when it comes to system acquisition. We're really just trying to see how much does AI enhance, where does it help, where does it not help, and then how can we quantify that when it comes to cost modeling. So some of the tools that we've tried out, ChatGPT, Gemini, Claude, Copilot, those are all pretty good. If you haven't used Copilot, I would highly recommend trying it out in VS Code. It does all your coding in line, so it's a pretty cool tool. But we really want to look at too, right, when we're designing something and then we're integrating it, we're writing the code for it. That's one piece. But then let's look back at the requirements. Can AI help us back in those system artifacts that are back in the requirements phase, all the way through the system engineering lifecycle, all the way through testing, and then all the way through the acquisition lifecycle as we move into sustainment. So some of the cost models in the past that we've used were Kokomo and CoSysmo. So we're really looking at how do we update those. So one of the objectives of the research is to develop a roadmap for advancing these cost models. What are some of the existing modeling and measurement frameworks that are out there, right? I mentioned Kokomo and CoSysmo. how those cost factors, how do we update those? Like I mentioned, measuring AI's advantages and pitfalls. I'll give you a brief example there. So I needed to model, or I needed a function to create well, not really a function. I just needed the ability to draw a random number from a normal distribution, but I needed to make sure it didn't go negative. So ChatGPT wrote me a really complex, and it worked, 40-line piece of code to do that. And then I said, okay, there's got to be a simpler way. A few minutes later, I said, simplify this to 5 lines of code, simplify it to 1 line of code. And then it had done a completely different way with 1 line of code. But if I had not known that the 40 lines was way too complex, I would have had a lot of excess code I didn't really need. So that also gets into the different usage scenarios and impacts across the systems and software engineering phases and activities. So that's just a coding example. But when we look at requirements, or we look at testing, or even some of my direct research deals in systems modeling, if I'm looking at allocation of parts to requirements, or defining the test criteria for a requirement, those kind of things also tend to do relatively well, but not perfect. So how are we going to measure how good we're doing and where we're going? So one of the things we want to look at is using a Delphi data collection instrument. You'll see a copy of what that form looks like here in a minute, or the initial form there. We also introduced the idea of query points as a new size measure. And what we're really looking at query points is to measure the size and complexity of AI generated solutions. So if you look at the paper, I won't cover all the details, but the details of how we suggest to create those query points are in the paper. And then we also want to look at, I mentioned requirements, design, and integration specifically, but throughout the system engineering process, in the bigger acquisition lifecycle in general, we want to look at how do we start quantifying that. So if you're familiar with Kokomo or COSISMO, you know there are cost factors. Here's kind of what we're looking at here on this scale. Nominal, it always sits at that middle point. Very low is currently the state of most applications over the last few years, where there's minimal or no AI assistance. I would say if you see any software development being done in the commercial sector now, we're at least in the low, where we're using occasional AI or regular use of AI. But you can also over depend on it and get some diminishing returns. So when the AI is deeply integrated and you're dependent totally on that, sometimes you'll get good results, but you might not get quite the return you're planning on. So data collection analysis methods, once again, how do we plan on doing that? We wanted to look at, I'll show you the form in a minute, but then some control group experiments. I want to highlight this Google Copilot study. So, or GitHub Copilot study. GitHub released Copilot in 2021. 2022, they did a study, and I have a few numbers here, where they started looking at this has actually helped developers. What they found was that 88% of developers they surveyed found that it made them more productive, or thought it made them more productive. And then when they actually tried to quantify it, they went back, gave some tests to some developers. They gave 45 were able to use Copilot and 50 were not. So we had a sample of about 95 people. 8% were able to finish 70% of the non-users were able to finish the report, and 78% of the Copilot users were able to finish the task. That being said, when they went and compared time, that's where the real time savings was. Of those who completed the task, the average for the non-Copilot users was 2 hours and 41 minutes. And for the Copilot users, it was 1 hour and 11 minutes. That's a very significant cost savings. Now, granted, these were already developers who already had a pretty good idea of what they were doing. And so like I prefaced it with, if you've never programmed anything in your life, you're probably going to get some mixed results. If you know what you're asking and you have some general idea of how to prompt it, you will get much better results. And it's a 10x force multiplier on that front. So we wanted to bring in the experts, so either software developers or systems engineers. So we're working with the BAME Center for Software and Systems Engineering. Also, that's where this forum is actually hosted, as you'll see in a second. And that's the softwarecost.org. Dr. Madachy has been involved with that group for a long time. But really, we're asking experts, hey, if you go through and you do this task, you can either, on method one here, estimate your effort multipliers based on some of the other, cost models. You can also say, hey, method two is to estimate your EMR. My favorite personally is method three, where if I have a task, I can estimate actual effort with AI assistant, how long it actually took me, and then the estimated effort without AI assistance, how long I think it would have taken me otherwise. Now, it's a little subjective, but right, so if we get enough people together, that's what the power of the Delphi tool will, or the Delphi survey will get enough experts together, and then we should get some pretty reasonable numbers. Not perfect, of course, but pretty reasonable. So our future work is to go ahead and institute this Delphi data collection, iterative analysis, and look at how we can implement that in Kokomo 3 as they update the cost model there. We want to look at the further analysis of AI tool impacts, and we're really aligning with ISO IEC IEEE 15288 as it is the standard. So we looked at how to CoSysMo, how do we make that open source? So Ryan Bell, who presented earlier, has actually done some programming there with Dr. Madachy to try to figure out how do we make some open source tools easy to use. The complexity of the queries, and I talked about this a little bit in my panel yesterday. If you ask the models for simple recall, they're very good, almost 100% accurate. Not all the time, but pretty close. When you start getting more medium and high complexity, that's where the accuracy starts to fall off a good bit. And so really we want to, how do we measure those impacts? And that's where the query points come in. And then to address a large scale team enterprise processes assisted with AI, how are these going to be incorporated into workflows, engineering processes across the board? And then one area we want to look at is addressing AI tool volatility and model updates. And as Iain mentioned, that's definitely a big key. These tools are new. They're coming out all the time. What you used 6 months ago may be junk tomorrow. It's a very fast moving field. So how do we keep it up to date and not buy something for 10 years when it's going to be out of date in 6 months? And we have references, and I believe I will pass it back over for questions.
Great. All right, I think there's a microphone in the back to be handed around so the people online can hear your question. And then if you have a question, please raise your hand or jump up.
So I have a question
Oh.
for Iain.
Very good. You have the privilege.
Oh, thank you.
You presented.
So
Go ahead.
can you create an AI that maintains the AI?
You can definitely use one to help.
Very good, Ryan. All the Ryans.
Yeah, my question's for Dr. Jose. So I'll preface my question with the background that my command is a matrix organization that attempts to match competency to project all the time, sometimes more effectively than not. Are you considering applying your research at the organizational level for command or project staffing, where we can allocate skills, see the skills that we do have, say on a new project that the organization is standing up, and be able to visualize the knowledge gaps that they do have in trying to allocate those gaps?
Yeah, so that's the next step. I mean, but again, you need the data, right, on what to map those things. And so first you need to create the map. So the network that was described at the end, I call it a map. It's really a network, and it's got these different clusters. And so one approach, so for example, what we have discussed is, so what's a good contracting officer and what skills does that contracting officer need, right? And so you could map it based on this network of skills and say, well, that person should fall in this case and should contain these different nodes that you saw. And so that probably could be related not only to contracting officers, but any type of need that you would have.
If I could ask a follow-on while the microphone's being passed. So as you were briefing, my question is, how do you determine if like words, when you do the semantic clustering, and you end up with these bags of words kind of thing, how do you know whether like words are truly the same word, or they're like a nuance of a community or a function or something like that? Does a human then have to go in and look at how you've sorted the words and kind of verify that?
So you put me in the spot because that's where the semi-automated part comes in,
Yeah.
right? There's a part in there that the human, so in every phase at the end, there's one section where someone has to go in and say, this makes sense, right? And that's the verification part that, in that case, that was me who says, okay, this makes sense. But if you really want to do it in a scientific way, you would have to find some type of experiment that analyzes and says, yes, this is correct. So one experiment that I was doing at the beginning was having a human actually create the summary and then compare the summary and find the skills. But obviously you cannot do this with 200 PDFs, right? Some of them are 1,000 pages. Who reads them? I'm always like, right? Yeah. I mean, who reads 1,000 page document in detail? This takes a lot of time. And so that's the part. And so, yes, so the clusters are analyzed for or verified. And then remember, those clusters are then sent to ChatGPT so that they can, I mean, this is the summarization part, which is generally very good, right?
Yeah, I'm just sorry. Super interesting. My thesis was on semantic matching. I'll send it to you later. The no, just the semantic distance between words. That there's multiple subjectiveness here. Like there's subjectiveness of the AI model and how it clusters things. There's subjectiveness of a human at the end that's like, yeah, that looks about right to me. And then there's subjectiveness of the person who wrote the requirement or the PD or whatever at the beginning. Like, did you really use the right word when you said what you wanted, kind of thing? And I think as we move forward, maybe with your research and automated tools like this, we'll start to get a point where it's not so much artistic expression when you're writing a PD or some sort of work role description.
Correct.
So
So that's
that's nirvana. Yeah. And then we'd be much more efficient because you'd be able to hire to that, you'd be able to recruit to that, you'd be able to kind of assess to that. So cool. Thanks for letting me do that.
No problem. So I'm from Nywick Pacific, so I understand your matrix organization from Nywick Land. We have obviously a very similar problem set here, and we're actually looking at doing this. We have some folks working on looking at our skill sets and doing some mapping with our projects and kind of predicting, where would this skill set work well. So I would love to do a follow-on and do some collaboration and work there. I was curious whether you looked at, I mean, I saw the documents that you showed, and I'll go read your paper for your list of sources, but whether you were looking at any of the OPM descriptions of, these are the different categories. This is what a 2210 does. This is what a general contracting officer does. And
so no, we didn't get that. That's yet another phase, right?
yeah,
So
yeah.
right now is just, so this is the data. What skills can we extract? What talent can we extract that is being talked about
Yeah.
in these documents, right? And you can see that, by the way, there's disorganization in these documents because
Mhm.
some belong to industry, some belong to NGOs, some belong to the government. And what I would really like to do is that we have a repository of that, right?
Mhm.
That allows me to differentiate on that, both by industry and by time. And so
Mhm.
I could go back to 1900s, right? And so the skill set that you needed to be, I don't know how old is this, the acquisition community, but we could say that it was a very different skill set that you needed then, now that you need now. And so we could start looking at this by time
Mhm.
and how it's changing,
Mhm.
right?
yeah, when we look at things like software programming languages, right? That's an issue, right? How many Ada programmers do we need, COBOL programmers versus now Python programmers, right? Unfortunately, we still need some of the former.
Right.
But yeah, looking forward to it and
Sure.
thanks, great talk.
Absolutely. Thank you.
I have a question from online, and it is from Ray Madachy. So Ryan, it's not for you, it's for Iain. And it says, Iain mentions an important new cost element for system acquisition cost models, the sustainment of the AI components. Great job collecting and analyzing the empirical data. We should collaborate. But why should AI costs be distinct from software costs? Software includes executable statements and data structures. Both AI and conventional software require custom procedures as part of the costs.
Yeah, it's a good question because there are elements. So all machine learning models, all AI models are software, but not all software is machine learning or AI, right? So I can build something that is just a function that executes some things and put test cases around it. And occasionally that function has to be updated and changed. When it's empirically derived in the way that machine learning models are, it has now different qualities to it that are different than, say, I wrote a simple function. Now you have things that have to be executed, like monitoring data and model performance. You have to do things like fine tuning. Fine tuning doesn't exist for a deterministic function. You just rewrite the function. And so there's these other kind of maintenance requirements that go on top of that. But you know, going back to the 2015 paper of hidden technical debt of machine learning models, the software is also really important as well. Everything from the operating system on up that has to be in place as in addition to now the machine learning bits that you put on top of that. So they are additive to that, and there are things that you have to do for machine learning enabled software that never would enter consideration for software by itself.
Terrific. Yep. Pastor Madachy, if you have reports or follow-on question, go ahead and type them in. Other questions from the audience? Sir.
Renee Rendon from NPS Acquisition Sciences Group. So I'm hearing that we're using AI and machine learning models to help government employees, government agencies to make decisions in support of decision making. And I'm hearing that we're thinking about using contractors, contracting out some of these activities and developing these AI models and machine learning models. Is there a risk that we may be allowing contractors to have an undue influence in how these models are developed to make these decisions, which results in a couple of things, that we may be actually contracting out inherently government functions, or we may have contractors having an undue influence in government decisions?
I think it's for you, Iain.
Yeah, that actually it's a good question, or a great. I think it's an insight, right? So I think there's two things I would say with that. The first one is what is warfighting in the AI domain? And by that, I mean, you mentioned this. What are the things that are inherently supposed to be service members doing? We don't have an answer to this. And more than that, I would say we disagree about it vehemently across communities. So, but you know, if I went to the CDAO Data and AI Summit back in February, to a vendor, every single contractor there that was selling a data-enabled product, when they said we bring AI to the warfighting, meant that the warfighter stares at a dashboard and that is it. They don't touch anything else in that AI pipeline. Conversely, we see things like the Artificial Intelligence Integration Center that the U.S. Army has. They run the AI Scholars Program. They're sending junior captains and senior first lieutenants to exactly the same master's degree programs that these companies hire their AI engineers out of. They're more than capable of doing this work as well. So we don't have agreement on what thing should a uniformed service member do. And this creates a lot of follow-on problems exactly like this, right? And it can lead to, because you could imagine, yeah, you could have an unscrupulous vendor that maybe they're selling a model that is meant to help evaluate contracts. And they have a little something in there that says, well, if it comes from me as this vending company, we're going to somehow prioritize that in the ranking. It's a very serious question and problem, and I don't have an answer for you, but that is a fantastic insight.
And while the microphone is being passed, yet and terrifying in other ways. So besides the acquisition of a system the contractor who writes the computer vision algorithm or trains the model that then goes on the sensor that turns the icon green and says that's a legal target to take kinetic effect on or to strike. Who is liable? Like who ethically? How do we have ethical controls on that? And so it goes to your like, what's a warfighting function? Who has that authority to make that decision?
So there's one other thing I realized with this as well too, sir. So the other part of this, and this is why we say a hybrid approach when we talk about this maintenance, there are just, you can't, and in fact, I remember I asked the outgoing CDAO director, Dr. Craig Martell, this directly, like, what is the role of AI experts in uniform? And his answer was, well, they shouldn't be. And part of the reason is because you will never get AI experts at scale in uniform. It's just never going to happen. And so you can't build everything in-house from the AI perspective, even with DoD civilians. And so some of this is just gonna have to be contracted out, both because you'll never have that skill at significant scale or depth to do it. But then on top of that, yeah, they're gonna do it better. Like OpenAI is gonna build a better large language model than I ever could. And so finding the way to balance that, maybe it's through regulations or how we write or something, that's a really important point, right? Like we have to rely on the industrial base for part of this.
Terrific. Yeah, another quote from Dr. Martell. Sorry. Yeah, AI models are a commodity, right? Like, yep, don't do it yourself. Just go buy them off the shelf and be a fast follower. Sorry, go ahead.
Dan Spies, follow up to your question. In our current environment of like manpower constraints, do you envision this being a new MOS that will be handling the maintenance? Or is this another, and if it's not, is this going to be another task we're asking soldiers to do? And are we overburdening them with maintaining an AI system on top of their current jobs?
That's a great question, Dan. So I have three responses to this one. So the first one is I'll plug my paper I have in, what is it, Joint Forces Quarterly, where I do look at that. It's data at the AI-enabled military workforce, right? The short answer to that is no, I don't think so. I think what we need to do is we need to relook at how we leverage the reserves for this type of thing, right? So you imagine our trauma surgeons that way in the Army, then we actually have most of those sit in the reserve population or National Guard. Because on the given day to day, with most Army things outside of war, we really don't use a lot of trauma surgery. LA General Hospital does though, and so it's better to let them go and be experts in that field, but be able to draw on that resource, on those chances when we need it, than it is to say we either have an all or nothing path. You have to be active duty doing these things or you're out. And so I think we need to relook at how we leverage the reserves with this, even to have things like reserve duty service obligations. What if you could go for your master's or PhD, but instead of having an active duty service obligation, you instead transfer to the reserves? So I think that's the solution is going to lie more in that one than it is, say, creating another MOS, because I don't think the structure is built, at least for the foreseeable future, to make that a viable path within career fields. Forgot the third one, but good, excellent question.
Please.
I think your area is gonna grow immense. I mean, I had not thought about maintenance of AI, and it's just so when do you even just, so my background is on reliability, so I'm stepping out a little bit of what the NLP. And so I'm just thinking about, oh, well, so are you gonna monitor these systems and decide when they need to be maintained? And so that's just, wow. I mean, it's very impressive.
That's right. That was the third one, actually, the crux of your question. So I didn't really answer your question, right? Yes, this is something that is going to filter down at various levels through the ranks, right? We're going to start seeing things like warrant. In fact, with someone the other day, one of our colleagues at the Army Cyber Institute, CW3 Price, 170 Echo. So he's an electronic warfare officer. I watched him with OmniSig by DeepSig go label data through their suite, retrain a model. They had already figured out all the steps on how the retraining's done, what's the right model architecture, all these bits, such that he, as kind of the operator on it, just knowing some things about, hey, I need to do a validation and a training split so I can assess what its performance on real world data will look like. And also that if I see a loss curve go down, and make sure I don't overfit. Few little bits like that, he was able to execute that as a domain expert and execute those tasks. So I think there's going to be something like that in there where we're going to see growth among certain career fields where they're going to have that. Maybe it's an ASI or Avid will be recognized, but yeah, that's a lot of those are going to filter down to those domain experts, I think.
Just wanted to, Eric on by the way again, Naval Postgraduate School Energy Academic Group. Wanted to follow up on something I heard you say about the reserves. Is anyone in the Army listening to you on that? And a honest question, because nobody in the Navy gets that for sure, for damn sure. Would like to just wonder if that's being talked about in the Army, what the way you think of reserves.
In small circles. And so, you know, it's the old, the pen is mightier than the sword. And so I continue to write on these things. And then when I do get chances to talk about it, I do. But has it entered kind of a serious discussion phase about it? No, I don't think so. And I think part of the problem is we haven't quite conceptualized what this program would look like, right? We actually have authorities to do a lot of the things within this. So for instance, we have direct commission authorities, right? Imagine we just modify that, we tweak. And by the way, direct commission authorities applies to direct commissions to the reserves too. So imagine we just modified that a little bit. Like if you had something where you were active duty, but you're becoming an expert such that you're no longer a domain expert that's using AI, you're now an AI person that occasionally wanders into other domains and helps out from time to time. Could we use that direct commissioning authority to say, well, let's give them a direct commission over to the reserves, and then we'll attach some reserve duty service obligation over to it. So it's there, but thinking through what should be the elements of this type of program, I don't think anyone's quite articulated it to sell it yet, but I think there are people that are thinking along these lines at least.
Just one last question, and going left to right, starting with you, Ryan, and that is this Gary Kasparov idea that what we want are centaurs, right? Like a human and a machine as a team will beat just the machine every time and just the human every time. And so as you were doing your research, are you starting to see where these two things separate out, where you'll have the machine will do this task or this aspect of the task, and then the human actually, you know, is better, more efficient, more effective, you know, more clever, or something that the computer cannot be, the machine cannot be, and I'm curious what those are.
Yes, I'll say, I'll go back to that GitHub Copilot study. One of the things they found was that Copilot really reduced the cognitive load on the menial task. So it really freed up the human to do the higher order thinking. And honestly, when I've been working with these tools, I found the same thing. If I can think at the high level and then break it, and as a system engineer, just kind of break it down into smaller chunks and then take those smaller chunks and put them out to the ChatGPT or Copilot or whatever, I get much better results back on those small chunks, and it allows me to think at the higher level without spinning a bunch of cycles on the low hanging fruit.
Great, thanks, Iain. Centaur.
I mean, I'm gonna parrot that answer. That was spot on. That's really it. It allows the human to kind of move up a loop in the cognitive thinking on these things, and ideally, I think your study really showed that, right? Like you could show it in a substantial speed up in your ability to do things. And when we talk about like speed kills in this realm of warfare, that's really, really important. Like if I can write code faster than someone else, if I can build models faster than them, if I can figure out plans faster, that gives you a distinctive advantage. And so, yeah, I'm gonna second that. Good response.
I hope you're writing all these down, because it's the new MOS manual or whatever, right? As you're creating these new jobs. I know when we went to like remote work during COVID or whatever, it's because we don't have a good sense for what we need people to do. So we can't measure them by their output or their impact. We end up measuring them by their activity or something, like whether their car's in the parking lot at 7:30 until 16:30 every day. And if we did a better job of understanding, you know, what are those higher cognitive tasks, then we'd be able to partition it out, right? Like, hey, computer, you do these, I'm going to do these other things. So I hope you're writing it down, because I'm not sure that we have it down yet. All right, Dr. Jose, bring us home.
I'm gonna write a haiku with the skills that I got. That's it.
That's what you're going to use the AI for.
No,
The Dr. Seuss thing for your child.
Yeah. No, I think so. I mean, so this whole project was created with AI, right? And so I think, yeah, I second. You can do things faster. You can do things better, and you can now. So I can play in different areas, at least for me, and I think that anyone can now move into things that are of their interest, and it's the learning gap is smaller now.
Great, thanks. Before I say thank you to the panel, I would I'd point out my Centaur example. And I've heard this to be true. I know one of part of it is true, but the other one I haven't verified yet. And that is when they were training Maven and the supervised learning for Maven, and they were doing the computer vision part. I was Marine Corps Intel School CO, and I had a bunch of young Marines that were waiting to start training. And so they would spend 8 hours a day looking at images and saying, yeah, that's a fire hydrant, no fire hydrant kind of thing, except it was planes on a runway or something like that to help train the models with labeled data. That's the true part. The story I've heard is that if you work at CENTCOM, like if your computer locks and you have to 3-finger unlock it or whatever it is, the way you're unlocking it is you have to do like 4 or 5 images where, so the commander of CENTCOM, in order to get back into his computer after he goes to lunch, has to label data. So have you heard this?
Oh, I've not only heard, I was involved in that. So their original plan was to
Samuel.
spend millions of dollars to do community colleges to do it. And I showed them a way they could use zero-shot image labeling so that they could do it in-house. The downside is now you get that problem. But
Okay, Major Cruickshank is now on the witness protection program. All right. A round of applause, please, for our great panel. And a special thank you to all 3 of you, one for producing a paper and submitting it, but then also having the courage to come up here and present your ideas and defend them and answer questions. So thank you, everybody, for joining us today, and have a great rest of your day. Thanks.
Thank you.